In this video, I want to talk a little bit about the APIs which provide system calls. So we already have this idea of what a system call is. Now in general, we're not going to make system calls directly. Instead what happens is your particular OS, right, so Windows, Linux, etc., will provide some sort of an API. So on Windows, it's like, for example, maybe the Win32 API, well, this is the older one. Or on Linux, it'll be the PostX API, right? So I have different APIs. Basically what these are, right, there are lists of functions that my program can call. And you can actually see an example of one of them on the right-hand side. So this is actually what we call a man page, which is man stands for manual. This is kind of a description of a function. So here, right, I'm actually looking at a function called read. And you don't need to worry about the details from this. This isn't something for you to specifically to know or anything like that. The idea, right, is that I basically have my API as a list of functions and a description of what those functions do and what can I expect from them. So here I'm looking at something called read, right? So this is telling me there's something called read, right? It's return type, it's parameters, what do they do? This though is just an example, right? So again, my OS is going to have many different functions that are available, right? Many different API commands that could be called. This is just an example of one, right? And this is maybe also useful for you guys because if you're doing some programming on Linux and you want to know more about a particular function, you can actually use this command over here, right? So over here I see it has basically man read over here. If I use that, I can basically get this output, right? So I can go and I can basically learn more about different functions that my OS provides. All right, so my OS has this API, ton of things in there, right? Read is one of them, write is another one, open is another one, all sorts of things are in there, okay? So why would I actually have that? The idea, right? So the idea here, right, somehow is that we're not going to make system calls directly. Instead, our OS provides an API. So this forms what we call an abstraction barrier, right? So rather than using things directly, I'm going to use them through this API. This is maybe a little bit awkward for people because actually if you go and look at it, right, so there is basically this list of the API that the user can use, and then there's internally, right, the OS's list of things it provides, right, and then this API kind of is a barrier between it, right? So you have your program, right, your program basically is forced to use this API. I guess we'll do a little diagram here, right? So you have your program P, then you have an API, which I'll draw as a line here. API. And I totally forgot that I have a pen here, so I'm going to switch to using the pen instead. And I have over here basically my OS. Look at how much nicer it looks when I write with the pen. It's awesome. All right. So anyways, so I have my program. My program, right, maybe needs to do something. It makes a call to the API, and the API makes a call to the OS, right? So this is how the world works, right? The alternative, of course, would be this over here, which is I have my program, my OS, and I do a direct call. That's not how the world works, right? That's not how it works. Instead, what we have is this little barrier in between this API. And the idea, right, is I'm decoupling my program from my OS, right? And I mean, sometimes, right, right, I'll have calls that basically the OS will make a call, the program will make a call, and the way the OS answers it is like directly, right? It doesn't do any sort of, work behind the scenes. Other times, it may have to do a little bit of work, right? There may be some sort of a translation that occurs. Okay, so let's see. So think about this. You have, for example, a computer running, for example, I don't know, say Windows 8. Okay, so Windows 8 has the Windows API. Imagine you write a program. Your program is going to use that Windows API. But then what you'd like to do is you'd like to have that program run also on Windows 10. Well, the problem is that internally, how the operating systems are built will change. So it would be bad for your program to rely on specific things from Windows 8 because then they won't be there in Windows 10 and you won't be able to use them, the program won't run. How do you solve that issue? You solve that issue by making your program rely on this abstraction barrier, this API, right? So rather than use Windows 8 features directly, use the Windows API. The Windows API will be implemented by Windows 8 in a way that's appropriate for Windows 8. When you go to Windows 10, you still have the same Windows API. The API doesn't really change. The operating system has changed, and the operating system will then, right, use Windows 10 features to implement that Windows API. And so because your program is relying on that Windows API, it'll run on Windows 8 or Windows 10, right? Because they basically have this common language, right? This common backend, right? This common API between them, right? It's going to be implemented different on Windows 8 than Windows 10, but they'll both implement it. And if your program relies on this API, it'll run on both Windows 8 and Windows 10, right? So this is our advantage here, right? Is portability, right? We have this abstraction barrier so we can write our programs against this API, and then the specific operating system will implement it in the way that it sees fit, right? And then we'll have this idea of something that's more portable, right? And this works, across different OSs, right? So I can have basically a program, right, that runs on all sorts of different versions of Windows, all different versions of Linux, because it relies on this API, which then your operating system supports, right? And so for some operating systems, right, maybe it doesn't do all that much work, right? So if the API was invented in the age of Windows 8, probably there's a very direct translation between those API calls and the internal Windows structure, right? Versus if I'm on Windows 10, maybe there's some other work that needs to happen, right? Maybe an API, because it was kind of designed with Windows 8 in mind, even though it can still implement it, it just has to do a little bit more work for it, right? But that's fine, as long as our programs use an API, then we'll be able to run them on different operating systems. All right, so the takeaway from this is the following. That basically the idea, right, is that we interact with an OS via an API, right? Sometimes we'll call them like an application. There's also this idea of an application binary interface, which we don't really need here. But there's basically this API, right, that guards our program for using the OS directly so that we can change the OS and the programs will still be able to use that same API, and different OSs can implement that API in different ways, and so our program will run in different places. All right, so that's the notion of abstraction APIs and making programs run on different OSs.